This week's lab is going to be focused on cartography. You'll be using NetCDF files to compare change in historic temperatures to a baseline. You probably haven't worked with NetCDF files before. This is kind of an interesting file format that stores multidimensional data. It's commonly used for meteorological data, so things like temperature, humidity, pressure, wind speed. Each of these variables can be displayed through a dimension such as time in ArcGIS by making a layer or a table view from a NetCDF file. We'll be downloading these files from a NASA, the NATA Goddard Institute for Space Studies. In this lab, we'll be focusing a lot on the nuance of symbology, and then you'll also be tasked with creating a legend that kind of goes beyond the defaults in ArcGIS Pro, so making, attractive looking legends. So this is an example of the data that you'll be working with. When you look at it, I think it's relatively intuitive. There's been warming. We're seeing a lot of really warm colors, which do symbolize, warmth. We feel warm when we look at dark red. But the time periods we're looking at aren't, we're looking at November through April, the average temperature from November through April from 2000 to 2020 compared to the same time period in 1951 to 1980, which, this isn't the most descriptive title. And this number is kind of just floating off to the side. That's the average warming in degrees Celsius, which is a pretty important value that's just kind of strung about there on the right. So we'll be working to make this labeling a bit more intuitive. And the reason is that climate doesn't explain itself very well, so you'll be helping through labels and annotations to explain your data to someone who randomly came across it. Think of something like a map that you might have seen in a National Geographic or Scientific American magazine. One thing that's very important through this lab is really explaining what you're mapping. So you're explaining the two time periods you're looking at compared to the baseline. It's very important to have all three of those things labeled. What period of the year? Are you looking at a whole year? Are you looking at just a month? Are you looking at a season? What's that compared to, and what the average warming or cooling, although, what the average warming has been. And as a bonus for those of you that made it to the end of the video, just a brief demonstration on why this map probably shouldn't have a scale bar or north arrow. There are very few, there's so many global projections, and they generally preserve either distance, direction, or shape, but they can't preserve all of those things generally. It's just flattening a round surface is very challenging. So often you'll see a lot of stretching at the northern and southern latitudes, with which climate data can be exceptionally misleading because it's so much warmer. Warming is much more accelerated around the Arctic, so it looks like a lot more warming than we're actually having. And I think you can kind of see, a scale bar, if this dude's face is the size of the map, it's the distance across his mouth is pretty accurate probably to the globe, but his hair has been exaggerated by like almost 3 times wider than it actually is. The same goes with north arrows. A north arrow is just not accurate on this map above, like 30 degrees north, because they should start, kind of pointing inwards, where if you just put one up, down, north arrow, it's not right. It's also not necessary. We're used to seeing the globe. We know how big it is, or it's hard to conceptualize how wide North America is in our minds. We also know that North America is in the northern hemisphere. We don't need a north arrow to tell us that. So it just clutters the map. It's not important, and most importantly, it's generally not accurate. In the next video, I'll show you how you're going to download the data and work with it in ArcGIS Pro.